Hi friends, in this video we are going to discuss about construction of synchronous machine. Constructional details of synchronous machine. Let's see. Generally, the basic diagram of synchronous machine. See here, for example, this is the outer part of my synchronous machine. How the outer part actually? See here. This is the outermost part of my synchronous machine. Outermost part of my synchronous machine is called as, they will ask you a question. What it is called as? This is called as stator frame. This is called as stator frame. This is also called as yoke in DC machine. But in synchronous machine and induction machine, it is called as stator frame. Stator frame contains stator winding and stator slots. Let's see. This is my slots of stator. These are the stator slots. The stator slots contains stator winding. We are placing the winding in these slots. So first one is the stator frame. Second one is the stator core. And next we have rotor. Ultimately, we have rotor. For example, this is my rotor core. What is there in between stator and rotor? In between stator and rotor, we have air gap. In general thing, we have air gap. So, stator frame, stator core, air gap, and rotor core, which having winding. This is called rotor winding. And next and last one is their shaft or prime mover. This is a shaft or prime mover. These are the main things of my machine. Of course, apart from this, we have a slip rings. Apart from this, we have a brushes. Brushes like this. Can you tell me brushes are made up of? The brushes made up of carbon or graphite. Why we are using only carbon and graphite? These are having self-lubrication property. That's why we prefer carbon or graphite. Okay. Then after, what is the purpose of brushes? The purpose of brushes is collection of current. It will collect the current from armature. This is a well-known thing actually. Are you okay? Listening or not? What about slip rings, sir? Slip rings are made up of hard-drawn copper. This is made up of hard-drawn copper. Generally, this is the media in between brushes and armature. In generally, in AC machine, we are termed as slip rings. But in DC machine, it is termed as split rings. Remember this. Split rings commutator. That is the one way of thinking, DC machine. But here it is called slip rings. And next, shaft. Can you tell me the shaft made up of, or prime mover made up of? The shaft or prime mover made up of carbon steel. It is made up of carbon steel. This is important. So these are the normal things. Now the main things are, one is the stator frame, next one is the stator core, and next one is the rotor core. These three are the main things. Of course, here we have a air gap. Actually, I am discussing about air gap in every machine. This is very important thing actually. In generally, in any machine, if air gap increases, for example, air gap increases, then what happens, sir? Yeah, tell me. Very good. If air gap increases, then automatically reluctance increases. If reluctance increases, then automatically flux decreases. Yes or no? Flux decreases. Then to maintain the same flux, in generally, in any machine, if air gap length increases, then automatically magnetization current increases, or no load current increases. This is the concept for what is that? Transformer and induction machine. But in any electrical machine, if air gap length increases, power factor decreases. This is very important for transformer, induction machine and synchronous machine. In any electrical machine, if air gap length increases, power factor decreases. Now one question. Now tell me, in synchronous machine, air gap length is, option A 0, option B minimum, option C moderate, option D maximum compared to all the machines. Option A 0, option B minimum compared to all the machines, option C moderate, option D maximum compared to all other machines. Now tell me the answer. Which of the following is correct answer? The air gap length in synchronous machine. Tell me the answer fast. Yeah, tell me. Is this 0? Is this 0? No, 0 is wrong answer. Now tell me, is this minimum or moderate or maximum? Tell me, sir. Here in synchronous machine, the air gap length is maximum compared to all other machines. This is final. Sir, why it is maximum? To get the minimum power factor, sir? No. Power factor is very important criteria in AC machines. We must maintain the maximum power factor. We should maintain around 0.8 to 0.9 power factor range. But I am saying you here, we should maintain the maximum air gap. Then how it is possible, sir? And why you are choosing that maximum air gap? These are the questions in your mind. Yes or no? So tell me first of all, why we are choosing the maximum air gap? Here we have another small relation. The stability is directly proportional to air gap. Stability is directly proportional to air gap. Always the synchronous machine should rotate at synchronous speed. For example, my synchronous speed is 1500 RPM. The rotor should be also exactly equals to 1500 RPM only. Then only it is called synchronous machine. For example, if the rotor speed 1501, it is not a synchronous machine, it is a induction generator. For example, if the rotor speed is 1499, it is not a synchronous machine. It is called induction motor. Be careful. Stability. Stability is very important. Sir, how we can increase the stability? Stability directly proportional to air gap. If air gap length is more, the machine is more stable. So tell me which of the following is the better option for synchronous machine? Maximum air gap. Maximum air gap gives us maximum stability. So we should maintain the maximum air gap. Sir, very good, sir. Good explanation. But you are forgetting that if the air gap length is maximum, power factor is minimum, then what you will give you the explanation for this? Yeah, sir. If air gap length increases, ultimately power factor decreases. But the very important additional advantage of synchronous machine is excitation, separate excitation of DC. By changing the excitation, we can control the power factor. This is very important point. Note down this point. By changing the excitation, we can control the power factor. This is the advantage of my synchronous machine. That's why we can change, we can improve the power factor by changing the excitation. Are you okay? This is the theory of air gap. Theory of air gap. Right? So now we have stator frame, stator core, and rotor core. Let's discuss about these things. We are going to discuss about stator frame and stator core. Let's see here. Tell me the answer. The stator frame made up of stator frame or yoke in DC machine, both are same. The stator frame made up of cast steel or cast iron. Cast steel or cast iron. Cast steel or cast iron. In generally, the cast steel is used for high rating applications and cast iron is used for low rating applications. Sir, what is the purpose of stator frame? The stator frame acts as outer protection layer. This is important. Here, this protects the machine from outer periphery. That's why it is called a outer protection layer. And also, it provides mechanical balance to our machine. Mechanical balance provided by this stator frame only. In DC machine, additional advantage is that, for example, this is my DC machine. This is my DC machine. Here, the yoke also provides flux path. Here, the yoke also provides the flux path. But here, the stator frame doesn't provide the flux path. There is no need of flux path. That is the difference between the yoke and stator frame. This is simply about the stator frame. Then next, what about stator core? Let's see. So, tell me, the stator core made up of? The stator core made up of silicon steel laminations. Silicon steel laminations. This is the 100% correct answer. In some textbooks, they will give you this is made up of CRNGO, silicon steel laminations. What is CRNGO? Cold rolled, non-grain oriented. No need of grain orientation for other than transformer. But for transformer, we should have cold rolled grain orientation. Other than transformer, non-grain orientation is enough. So the stator core made up of silicon steel laminations. Sir, why we are going for laminations? By using laminations, we can reduce the eddy current losses. We can reduce the eddy current losses. Sir, how we can reduce the eddy current losses by using laminations? Due to laminations, the volume of the core decreases. We know that R is equals to rho L upon A. If it is multiplied with length, this is area into length, nothing but volume. If volume reduces, resistance increases. Nothing but the resistivity of core material increases. If the resistivity of core material increases, then eddy currents are circulating currents. Eddy currents are circulating currents in the core decreases. If the eddy currents reduces, then automatically eddy current losses also reduces. This is the laminations. The lamination thickness 0.35 or 0.5 millimeters. In generally, we are using 0.35 millimeters. What is laminations? Laminations nothing but thin parallel plates. You know about that, right? Next one. Why we are using silicon steel only? Why not the other? Generally here, for silicon steel, the hysteresis coefficient. What is this? X? X is the hysteresis coefficient. Here, for silicon steel, hysteresis coefficient value very less. How much it is? 1.6. Actually, hysteresis coefficient range is 1.5 to 2.5. But the practical minimum value 1.6 for silicon steel. If the hysteresis coefficient is less, then automatically hysteresis losses also reduces. This is the hysteresis losses. What is the formula for hysteresis losses? Neta B max whole power x F into V. Here neta is a constant, Steinmetz constant, and x is the hysteresis coefficient. If x reduces, hysteresis losses also reduces. This is simply silicon steel. How much percent of silicon is added to the steel? How much percent of silicon is added to the steel? Just 4 to 5% of silicon is added to the steel. This is simply the stator core construction. The stator core made up of CRNGO silicon steel laminations. Remember this. Sir, what is the purpose of stator core? The stator core provides accommodation for stator winding. Which type of winding we are using here? which type of winding you should prefer for stator of my synchronous machine. Don't say armature winding. Of course, it is a armature winding. I asked you which type of winding. Short pitch winding or full pitch winding. Concentrated winding or distributed winding. Of course, it is a armature winding. But which type of armature winding we preferred here? In stator core, we preferred short pitch distributed winding. Here in stator of my synchronous machine, we are using short pitch distributed winding. This is an important thing. And here the stator inner periphery is slotted for winding. Which side? Inside or outside? The inner periphery is slotted for winding, which is a armature winding, and this armature winding is a short pitch distributed winding. It is a short pitch distributed winding. This is simply about the stator core. Right? The next one, rotor core. Rotor core made up of CRNGO silicon steel laminations. Again say, the stator core and the rotor core both are made up of CRNGO silicon steel laminations, and the explanation is same for construction point of view. But here in this rotor, we have two types. One is called, one is called salient pole rotor. Other one is called non-salient pole or cylindrical type rotor. Synchronous machine rotors are two types. One is the salient pole rotor, other one is the cylindrical type of rotor or non-salient pole rotor. And here the rotor outer periphery, see here outside winding. Rotor outer periphery slotted, stator inner periphery slotted. So here rotor outer periphery slotted for winding. This is the construction point of view of stator and rotor cores. Right? Here the thing is that, the remaining thing is that we have to discuss about the salient pole and cylindrical type of rotors, how they are, and what are the differences between salient pole and cylindrical type of rotors we have to discuss, right? So apart from this, this is the construction of our synchronous machine. Stator frame, stator core, rotor core, air gap, slip rings, brushes and shaft. This is the construction of synchronous machine. Thank you.